Hello and welcome to our educational video on kinetics. Kinetics is the branch of chemistry that studies the rates of chemical reactions and the factors that affect them. Understanding kinetics is important because it helps us design and optimize chemical reactions in industries such as pharmaceuticals, materials science, and environmental science. Part 1. Reaction rates and rate laws. To begin with, let's define reaction rates. Reaction rates are the speeds at which reactants are converted to products. Factors that affect reaction rates include temperature, concentration, and the presence of a catalyst. The rate law of a chemical reaction describes the relationship between the rate of the reaction and the concentrations of the reactants. Let's take the example of the reaction between hydrogen gas and iodine gas to form hydrogen iodide gas. The rate law of this reaction can be written as rate equals K, H2, squared, I2. This means that the rate of the reaction depends on the square of the concentration of hydrogen gas and the concentration of iodine gas. The constant K is called the rate constant, which depends on temperature in the specific reaction. Part 2. Reaction mechanisms. In some cases, reactions occur through multiple steps or intermediate reactions. Reaction mechanisms describe the step-by-step sequence of reactions that make up the overall reaction. The slowest step in a reaction mechanism is called the rate-determining step, which determines the overall rate of the reaction. Let's consider the example of the reaction between nitrogen dioxide and carbon monoxide to form nitrogen monoxide and carbon dioxide. The reaction mechanism involves two steps, with the first step being the slowest. The rate law for this reaction can be written as rate equals K, NO2, CO. Part 3. Activation energy and reaction rates. One of the factors that affect reaction rates is activation energy. Activation energy is the minimum energy required for a reaction to occur. The higher the activation energy, the slower the reaction. A catalyst is a substance that lowers the activation energy, which increases the reaction rate. Let's take the example of the reaction between hydrogen peroxide and iodide ion to form iodine and water. The activation energy for this reaction is high, which means that the reaction is slow. However, the addition of a catalyst such as manganese dioxide lowers the activation energy, which increases the reaction rate. In conclusion, kinetics is an important branch of chemistry that studies the rates of chemical reactions and the factors that affect them. By understanding reaction rates, rate laws, reaction mechanisms, activation energy, and the role of catalysts, we can design and optimize chemical reactions in various industries. We hope you found this video informative and useful. Thank you for watching.